This is a very brief video on naming acids. They have their own set of rules. So first I want to make clear that you know what an acid is. It is a covalently bonded compound, even though it ends up producing ions. It starts out as a covalently bonded compound. And by definition, it produces hydronium or hydrogen ions. Now, we'll get into acids and more about their chemistry later on in general chemistry, but just for now, this hydrogen ion exists pretty much kind of piggybacking with a water molecule, and we call that a hydronium ion. That's actually a polyatomic ion. So when you see the hydrogen ion, the naked hydrogen ion, it is considered by chemists to be equivalent to the hydronium ion. All right, so again, an acid is something that produces hydronium or hydrogen ions. Typically, you can identify an acid easily by its formula because the first element in the formula is usually hydrogen. Just as there were several different types of ionic compounds, there are two main categories of acids. One is a binary acid, and again, that's just one made up of only two different elements, and that would be something like HCl. The other category is a ternary, also known as an oxy acid, which has three different elements. And so there are different naming rules depending on whether it's binary or ternary. So that's the main differentiation you need to get out of this PowerPoint. Let's start with binary acids. And again, that is an acid that is made up of only two different elements. So HCl is a very common one, but let's see, H2S would also be binary. Now, I wrote this on purpose because binary does not mean only two atoms. It means only two different elements. You can have as many atoms as possible as long as there are only two different elements. Okay, so the rules for binary acid is, first of all, always starts with the prefix hydro. Then you have the hydro represents the hydrogen, right? Then you have the root name of the non-metal, the anion, but it has a suffix of ic, ic, and then it's always ended with acid. So let's put that together in an example. So let's do HCl, okay? Always start with hydro. That is chlorine, so we're going to start writing chlorine, but we're going to put a suffix of ic on it. So hydrochloric and then acid. All right, that is binary. Ternary, also called oxyacids, are trickier to name. It is another time when you need to have polyatomic ions memorized. So not only to name ionic compounds, but also to name acids. And the rule for ternary naming, they all have a polyatomic in them, okay, is that if the polyatomic name ends in ate, okay, so that might be sulfate, nitrate, phosphate, any of those that end in ate. The acid version name of it will end in ic. So if you have an acid, for example this, and you identify the polyatomic in that acid as a sulfate, that means the name of the acid that it participates in will end in IC. So this, and you may already know this, it's a pretty common acid, sulfuric, I put two I's in there, whoops, sulfuric acid. Right, so if the polyatomic ion name ends in ite, and in case you didn't already notice that, by far most of the polyatomics end in either ate or ite. Okay, ate or ite, ate or ite. All right. So if the polyatomic name ends in "ite," the acid name that polyatomic is composed will end in "us." So let's compare sulfuric acid to, let's say instead of the sulfate ion, let's say instead of SO4 we had SO3. That happens to be the sulfite ion right here. Okay. How would we name the acid? It would be, instead of sulfuric acid, it would be sulfurous acid. All right, and so the little memory thing that I've always used and tell my students is that he ate ick and got stomach ite us. Okay, he ate ick and got stomach ite us. So that just kind of helps you remember that ate and ick go together, right? And ite and us go together. Alrighty. Here's some practice. So you need to be able to go in both directions as normal. So if you're given a formula, you're expected to be able to give the name. So the first question you should ask yourself after you've identified it's an acid, and how do you know it's an acid? If it's a formula, it starts 99% of the time starts with a hydrogen, all right? This is binary, there are only two different elements, so you just remember the rules, okay? Hydro, it always starts with hydro. That's bromine, but we have to change the suffix to ic. Hydrobromic acid. All right. Then, of course, if you see one that has more than two different elements, this one has hydrogen, carbon, and oxygen, that is a ternary acid or an oxyacid. Identify the polyatomic ion in it, in this case CO3. Need to memorize those names. That happens to be carbonate. CO3 is called carbonate. He ate ick, so that means the acid will end in ick. So the acid is carbonic acid. Right? And we kind of already named that on the last thing, right? That is sulfite. Ite us, so that becomes sulfurous acid. Alrighty, so here's an example just to get you used to looking at formulas and names. So let's look backwards on these, okay? Let's say you were given the name chloric acid. How would you go about getting the formula? Well, what I would do, I'd say, okay, it ends in ick, and it doesn't have hydro. It doesn't have hydro, so I know it's not binary. It's a ternary. It has a polyatomic ion in it. So the ick means the polyatomic ion would end in 8. So here's the polyatomic ion, ClO2. And so if you hadn't memorized it, you would have to look back at your polyatomic list. And 8, so chlorate would be the polyatomic, and chlorate has a formula of ClO3. The formula over here says ClO2, so there's a mistake there. Okay, now read the instructions that said which of the following shows the correct formula with the correct name. So it's not A, we found a mistake. So let's approach it from that side again using phosphorus. That ends in us, meaning the polyatomic it was from ended in ite. So phosphite, okay, would be the name of the polyatomic. And phosphite has the formula of PO3 with a 3 minus. Look at that. Those match. Okay, so just to make sure we didn't make a mistake, let's look at C and D. Hydronitrous, okay, I immediately see an issue there. The hydro implies that it's binary, right? Only binary acids start with the hydro prefix, but the OUS implies there's a polyatomic, okay? Polyatomics are never binary, they're always ternary, so that right away tells me that's an impossibility. And HI, okay? So HI, I'm gonna go the other way here, it just makes more sense, is binary clearly, right? And so let's name HI. It's binary, so we're gonna start with hydro prefix. And then I is iodine, but we need to change the suffix to dic, hydroiodic acid. And you can see now that there is an issue because they forgot there. You can see it a little bit now. Because the name they gave it is missing the hydro. So that's a problem. So the only one we were correct, the only one that is correct is C. Okay, we're closing in on the end now. How do you know that you're dealing with an acid? Well, all names, whether they're binary or ternary, after their technical name will have the word acid, okay? And so the first thing that you should do when you're writing the formula is start the formula with H. Remember that virtually all formulas for acid compounds start with H. Now, one thing that I do want to point out, so tune in real strongly, focus real strongly for a minute, is you have to determine how many hydrogens you need in that formula. And as I've told you repeatedly before, every single compound in nature overall is neutral. It's okay to have plus and minus charges, but they have to neutralize each other. Otherwise, it won't be stable. So, for example, let's say that you found the polyatomic that's in an acid is sulfate. And don't forget the charges. I mean, they had a charge of -2. You cannot just combine one hydrogen ion, in this case, with the sulfate polyatomic ion, because what does the overall, that has a net charge of -1. So you're going to, what determines how many hydrogen ions you have in a formula is how many it takes to neutralize the anion. So since you have a -2 charge here in the anion, you need H2SO4. Okay, so if, let's say, phosphate, which is a -3 charge, if you wanted to make the acid from that, it's 3 hydrogen ions to neutralize that -3 charge. So be careful with that. So just a couple of hints for you. Remember that the first thing you do if you are writing a formula for an acid is ask yourself whether the name is that of a binary acid or a ternary acid. And you'll know that because remember, binaries start with the prefix hydro. So that's the first question you should ask yourself. Then identify what the anion, the negative charge of the acid is, okay, because every acid is composed of a hydrogen ion and then some anion. Okay, well, it doesn't have to be -1, but some anion with a negative charge. Make sure that you write the charge of the anion there so that you can add as many hydrogen ions as are needed to neutralize the overall compound. And that's it for naming acids.